what is gravity? I mean, we talk about gravity and we see the spoon fall to the floor, and we say, yeah, that's gravity, and that's as far as we go. We don't know what it is, what caused it to do that. I mean, if you see someone pulling on a donkey, you say, well, I know what caused the donkey to move forward. It was the fact that this guy was pulling on a rope. Okay, so we know what caused the donkey to move forward. Okay, and it's straightforward, and it's just self-evident. But when you say, look, what caused this to fall to the floor? We say, well, I don't know, but it happens all the time. And we call it gravity, and that's it. We have a name for it, but we don't have an explanation for it. We don't have a physical interpretation after 3,000 years. Okay? And what is the issue? The issue is that the only issue, the reason no one has an explanation, is they cannot see or touch the mediators that cause this to happen. That's the only reason. See, if we could see, we had God's eyes and we could see what's there, whether something pushing or something pulling, we would say, okay, that's straightforward. Something's pulling on it or something pushing on it. And it's this, because I can now see it, I can make it visible for you. But as long as it remains invisible and untouchable, it's stumped all the researchers throughout history. And that's the only reason we cannot explain it, because we cannot see or touch the mediators. But what's the issue? The issue is if you do not mentally put in there some visual, some entity, some things, some objects, then you're explaining this with black magic. You're explaining gravity with black magic. Okay? So you're saying it just happens by black magic, by remote control. The earth pulls on it somehow, or maybe the moon pushes it on it somehow. All you're saying is that there's remote control. God is doing it, the angels are doing it. And what mathematical physics has done all these years is put concepts in there, and they say it's force, it's field, it's mass. And then the flat earthers say, no, it's density. And they have all these words, and they don't realize none of them are physical objects. We need to know what physical object is pulling or pushing on the spoon. If you do not put a physical object pushing or pulling, you are essentially explaining this phenomenon with black magic. So you cannot use words such as density, mass, gravity, force, field, concepts. You cannot put concepts to explain that phenomenon. That's the bottom line. And so that's what we have today. We have just concepts. So people are explaining it with black magic. And so one fellow asks about my site. He says, how about you, Bill? Okay, so apparently he wasn't familiar with what we do here. Okay, so he asked the following. He says, you explain that every atom is interconnected to every other atom in the world. Correct. That's what we're saying. In the universe. Not only our world, like our planet, the entire universe. Every atom in the universe is connected to all others. Okay, I want to make sure that's clear. Okay, what is the physical nature of the interconnection of all atoms which pulls on all other atoms? Okay, that's the question, and he wants answers specifically. What is causing that force which binds all objects together in a pull? Okay, repeat more or less what he wants to know. Okay, science without experimentation is only philosophy. Well, there he's totally wrong. Again, he's got the wrong scientific method, the irrational scientific method. He's saying that if I run an experiment, okay, and I'm going to run an experiment, and there it is, there's the experiment. I let go of the spoon, okay, I'm not throwing it, I'm just letting go of it, okay, and it always falls to the floor by magic. And he's saying, without experimentation. Well, I did an experiment. So what is this, just philosophy? People want to know or understand, right? What causes this to fall? And he's saying that's philosophy. If you don't do an experiment, well, I'm doing an experiment, and so does that make it physics because I did an experiment? So again, he's got the irrational notion of what science is, okay, what physics is. Another fellow similarly asked about this site. He says, Bill, which theory do you follow on the mechanics of cosmology? And I guess he's referring to electric universe, flat Earth, not quantum mechanics, but general relativity, string theory. He's talking about cosmology, talking about the big picture, how the universe works, gravity at the universal level, right? And so he wants to know how that works, according to, which one I subscribe to. And the first thing I want to make sure I don't subscribe to any of those, okay? Don't subscribe to flat Earth. I do not subscribe to electric universe, general relativity, string theory, or even quantum mechanics, which is not a cosmological theory, but I don't subscribe to it either. None of those have anything to do with rationality, with physics, with science, with anything. All those are irrational. Therefore, they have nothing to do with science. So I don't subscribe to any of those, okay? But I do have something to propose in the alternative, and that's what this site is about. Okay, and yes, it has to do with interconnectivity because we're going to show that gravity is not an action at a distance phenomenon. Gravity is just like any other phenomenon. The only difference between regular everyday phenomena is that we can't see the mediators. We can't see or touch the mediators. That's the only issue. If we could see and touch them, it would be kindergarten stuff. You would say, okay, I see what's causing this. Something is pulling on it, which is on our theory. We're saying there's a pull there, okay? But, as long as you don't see anything there and you're expecting to see or touch something, you say, let's go to the lab. Let's run an experiment. Let's use our eyes and our hands to detect what's causing this. And you're an irrational individual because Mother Nature, Father Universe, God, the devil, whoever you believe in, they don't do gravity with visible and tangible things. Their mediators are invisible and intangible. They're things, they're objects, they're entities, but they're not visible or touchable. And until you grasp that, you're going to chase your tail around forever. That's the story from this site. Okay, so let's go with what someone proposes here, and that's quantum mechanics in general, or you could say it's really mathematical physics in general. I put quantum mechanics, but because that's the one that deals at the microscopic level. But really, this is all of mathematical physics, and in fact, this is what they have proposed for 3,000 years. What you see there on the left-hand side is discrete particles, just forming part of the vacuum. Some people equate it with a vacuum. Some say that the particles are floating in the vacuum, okay, in space. Okay, there's these two versions out there, but what you're staring at is the ether. Okay, the ether is a bunch of discrete particles that form the backdrop to everything out there in the universe. That's what the ether is. That's how the Greeks conceptualized it, and nothing has changed in 3,000 years. Anyone who says that ether is anything other than what you see there, a bunch of particles, does not know what the ether is. And so the onus is on that person to one of the two: either draw, illustrate, take a photograph, make a mock-up of a statue or whatever of the ether, or define the word ether unambiguously. If he cannot define the word ether unambiguously, he cannot even start his presentation. We need to know exactly what the ether is and whether the ether is equivalent to space, vacuum, nothing, or whatever you want to call it, or whether the ether, meaning these particles or whatever the ether is inside. It's contained, so to speak, within space. In other words, if ether and space are two different things or the same thing, that's what we want to understand before he can start his presentation. We need to know if it's a physical object or if it's an abstract concept. A concept is something you define. An object is that which you can point to because it has shape. And if it has shape, there should be no reason for anyone to have an excuse to say that they can't draw it, they can't illustrate it. On the other hand, what do we propose? The rope hypothesis, there you have it, interconnected atoms. All atoms in the universe are connected, bound to each other by something that is there that we cannot see or touch. In fact, we cannot see atoms. So for people to request to see the mediators that bind two atoms, it's irrational because we cannot even see atoms. No one has ever seen a hydrogen atom, let alone what interconnects two hydrogen atoms. Okay, so until you get a grasp of that alone, you got a long ways ahead of you, because you don't understand half of it yet. Okay, so what happens here? We have two atoms, okay? And you can see what quantum mechanics, essentially mathematical physics, proposes, okay? And that's the quantum atom. You have a little ball in the center called the proton. They call it a positive particle. We don't know what positive is, okay? Positive is just the opposite of negative. They could have said it's the A or the Z. They could have said it's west or east. They could have said north and south. They could have said any two opposites. They could have called one the yes and the other one the no. That's what positive and negative really mean. We don't have an idea from the mathematical establishment what positive and negative mean in physical terms. So they put a plus sign and a negative sign, these ridiculous symbols, to say they're opposite, whatever opposite means in physical terms. And so that's the atom, and that little red ball, that's called the electron. It's supposed to go around or somewhere around the proton, and that's why those dotted lines, essentially, it's an orbit, and they call that orbit an orbital. That they have converted the region in which you can find an electron be, they call that an orbital. So the region, which is a concept, has been turned into a physical object, some kind of shell of sorts, okay, like an eggshell. And then one atom can influence another one through what they call entanglement or through gravity or through whatever action at a distance that they want to talk about. And what is action at a distance? There is no mediator between two atoms. These are all discrete particles. They are discrete atoms. And even within the atom, we have discrete particles that we have no idea what binds them together. We have no idea why the electron doesn't spontaneously leave the atom, or why it doesn't fall towards the nucleus. Why does it remain in a region known as the orbital? Okay, that or energy level. That's what we want to understand, and we don't have an answer to that. And mechanics, the quantum mechanics people, they just say we don't understand it either, but let's continue. Okay, that's the way it works. And a lot of people think that they do understand it because otherwise we wouldn't have all the technology that we find out there. Okay, on the bottom you see the rope hypothesis. We have a physical mediator, okay? And that means that one atom is bound to the other physically. So they can't leave, like one atom can't leave the universe or the space. First, because space is nothing, a synonym of nothing. That means it has no shape. Nothing can leave that which has no shape. You have no border to cross. That's one reason. But even assuming space had a border, surface, the atom couldn't leave it because it's bound to all other atoms in the universe. Right? And so that's you can see the difference there. Our atoms are bound; their atoms are not, and our atoms have this three-dimensional atom that you see there. It's essentially made of the same thread that forms the rope. Okay, that's why it's called the rope hypothesis. And one of those threads goes around and forms the electron shell, and all the threads from every atom in the universe weave around and comprise the electron shell, while the other thread that forms the rope goes right through the center of the atom and forms what we call the proton dandelion or star. Okay, so we have all these threads that form the atom itself. Okay, so not only do they form the rope, but the atom that's built from the same threads. Okay, so that's the proposal. Okay, and here we see them in motion. Okay, you have the quantum mechanics version up there. We have a little ball that somehow falls between these two energy levels. It doesn't fall all the way to the center of the atom, which is that blue ball, which they call the proton. Okay, and at the same time, it doesn't leave the atom itself unless it's ionized, forming what is going to be called plasma. A bunch of atoms which are ionized, that's plasma. Okay, and again, they have this action at a distance. It's black magic. That's what action at a distance stands for. Whenever you hear that, you hear black magic, because they're saying there's no mediator, but one atom influences another, even if it's at the other side of the universe. That's what these people are telling you. Okay? Okay, and at the bottom you see our model, and that is that the atom is a membrane, which we call the electron shell, which encapsulates the proton star. Okay, and all of this is made of the same thread as the rope which binds any two atoms. An atom can approach another one, and it does so by swallowing thread from the rope. Okay, so as it pumps back and forth, which is what we call the quantum jump, it approaches another atom by sliding, or like a bead on an abacus, essentially. It doesn't take the wire with it. And this is more or less the same thing. An atom just approaches another atom, eating rope as it approaches the other one, until, for example, it can form the H2 molecule, which means that there is no more rope between them. What we have at that point is just the merged shells. Okay, so this is the proposal. This is what we propose in exchange for quantum mechanics and mathematical physics in general. Okay. Okay, so one fellow brings up, and he summarizes essentially the cosmological version that mathematical physics has for gravity, which is what we're talking about right here. Okay, and this is it. He says general relativity, Einstein's theory of gravity, is the geometric theory of gravitation. Geometric because they say it's the modification, the distortion of space-time, which is supposedly this four-dimensional medium. Okay, an ocean, think of it like that. Okay, but it's a four-dimensional ocean. That's how they're going to illustrate it. Okay, usually in two dimensions. Two really. It's a 3D projected onto 2D platform. That's what you see there. Okay, the current description of gravitation in modern physics. Yeah, modern mathematics. Okay, modern mathematical physics, which is not physics at all. General relativity describes, and see, he's talking about description and describing. Okay, yeah, mathematics can only describe, and that's what general relativity is. It's a description. The explanation, the physical interpretation, is totally irrational. Bunk. It's nonsense. But what the mathematicians are concerned about is the mathematical description. That's what general relativity is, just a description. That's why they love it so much. Okay, describes how properties of the world change in the presence of sources of gravity. General relativity explains the laws. No, first we have no laws in physics, and certainly general relativity doesn't explain anything. The explanation is, again, warp time, warp space, and that's not a rational explanation, meaning it's no explanation at all. It may be in ordinary speech, in religion, that could be called an explanation, not in physics, not in science. An explanation has to be rational in order to be an explanation. Okay, so it explains the law of gravitation in its relation to other forces in general in nature. Okay, so what is uh, a rational explanation? Because this is an irrational explanation, therefore it's no explanation at all. This is not an explanation to say that time warp. Okay, time is warped, and that's what prevents the Earth from flying out of the solar system because time is warped. No way, you can't do that. Not in physics. Okay, and so here we have the criteria for irrationality. Okay, irrationality. The main one is number one: treating concepts as objects. Okay, reifying objects, concretization. Okay, and what they're doing is they're turning words such as field and energy, mass, into physical objects, and they start moving these things around. They're saying, "Oh, we transferred energy. The field is vibrating. It's an excited field, and the mass moved, and so on." No, you can't do that. Not in science. So those are irrational physical interpretations. When you put a concept, you start moving it, vibrating it, whatever you do with it. Using inconsistent or undefined words, inconsistent definitions or undefined words. The theory doesn't follow from the hypothesis, from the assumptions. Okay, the explanation doesn't follow from what you presented up front. Describing and claiming to have explained, and the mechanism cannot be even imagined. Okay, so whatever when general relativity says that um, gravity is the something to do with space time, meaning that it's the warpage of space time or the bending of time or anything like that. Those are irrational explanations. And if it's an irrational explanation, you cannot even imagine it. I mean, what are you going to imagine for warped time, for bent time? What is that? The seconds are bent? Is that what these people are saying? Okay. And so, maybe here you can see a little bit of that. Okay. Here's Einstein. He says he warps the seconds, the time warp. Okay. Is that what we're supposed to visualize? Is that what we're supposed to imagine, that time is warped, meaning the seconds? Maybe it's the minutes, the years. I don't know. Whatever unit they want to put in there, or maybe they're warping something else. Maybe they're talking about a different kind of time, like this one. Money. They say time is money. Is that what they're talking about? Is that what they're warping? All these people who are the disciples of Einstein today. Okay, so yeah, this is the problem. The problem is that you cannot say that you're going to do time warps and that's an explanation for how the universe works or why the Earth doesn't fly out of the solar system. Okay, and this is essentially what they're saying. Okay, in general relativity. Okay, that there's a wall of time. It's a curved wall of time, and that's that depression that you see underneath the sun there. So the sun somehow weighs this down with its mass, because it's not the sun, it's the mass of the sun that's weighing down the canvas. And what is the canvas? It's length, width, and height plus time. Okay, so essentially we don't care about length, width, and height in this case. We're saying that what the mathematicians are saying is that mass is pushing down the canvas that includes time, and therefore time is a wall that prevents the Earth, or one of the components of this space-time thingy, that prevents the Earth from flying out of the solar system. That's what they're saying. Okay, and yeah, it's like the roulette mechanism. So you don't have to be a genius to understand what these people are saying. They're saying that mass warps space time, meaning time. Let's forget about space for a moment. It warps time, and that warp time is what prevents the Earth from flying out of the solar system. Obviously, it's unimaginable, and if it's unimaginable, they don't have a physical interpretation. And the question is, why did they even attempt to give a physical interpretation if mathematical physics, does not provide physical interpretation, if that's philosophy, as they call it? In the end, when you put them against the wall, they say, well, that's philosophy anyways. It's opinion, so to speak, religion. They don't care about it. And you say, why did you even attempt to give a physical interpretation to your equations if you're going to give an irrational one and at the end say, well, it's just philosophy anyway? See, this is the issue. The issue is these people claim to know how the universe works. They don't know how the universe works. They don't understand how it works. And then they say, well, that's philosophy anyway. That's where we're at today. Okay, what's the quantum version? Because that's the cosmological version. How about, this little spoon and falls to the floor. Okay, and you say, well, why did that fall to the floor? How does quantum explain this at the everyday level, at the micro level? Because relativity again is out there. Relativity is not used to explain this. Okay, or even describe this. There is no warped space near the spoon so warped that it creates this effect. Okay, a lot of people don't understand that. They say, "Oh, general relativity explains it." No, general relativity does not work here on Earth. It works out there at the macroscopic level. So general relativity is a cosmological theory, not even a theory; it's a description. Okay, mathematical description, but it does not explain or purport to explain this. And he who doesn't understand that is not even a relativist; doesn't even understand relativity. But yeah, this is the world of quantum mechanics here, the world of everyday life. We're talking about the microscopic level for quantum mechanics, and you have to explain gravity there. But this world here, the regular world, has to be explained also in terms of quantum mechanics, not in terms of general relativity. So how do they explain it at the microscopic level, the subatomic level? Well, here it is. Okay, this is, you won't believe it, but this is the way they explain attraction in general. Okay, here's two quarks being pulled together by a gluon, but a gluon is a particle. Okay, that's what they claim it is. And so here's a quark throwing a gluon on another quark, but it attracts it. There's this attraction between quarks. Okay, they don't fly out of the solar system, meaning the little atom, that little solar system. They don't fly out of there. Why? Because the gluon keeps them together. Okay, so how does a quark do it? Well, it throws a gluon at another quark, and somehow, because the gluon goes outwards, it pulls the other quark towards it. That's what it keeps, the quarks together. And you say, how is that possible? That doesn't make any sense to say you throw something at another quark and it pulls on the quark. How do you explain that? And here you have a fellow who died a couple years ago. His name is Victor Stenger, and he was a physicist. And this is what he has to say. It says the vacuum is capable of producing interactions between particles at effectively space-like separations. And it says, let me explain. No doubt the idea of motion backward in time makes a grievous attack on common sense. However, to a particle physicist raised on a diet of Feynman diagrams, motion backward in time is not at all that disturbing. All fundamental particle interactions work backward as well as forward. Okay, and so these people just do mathematics, and what they're doing is they're saying, look, to throw a particle at something and attract it is not, not beyond the mind of a mathematician. And again, these people are not doing physics; they're not doing physical interpretation. They just get away with murder, saying it is so, and that's it. So all they're doing is saying, yeah, if you throw a stone at a donkey, you attract it. That's what they're saying. And you say, well, how is that possible? How do you conceptualize that? They call it negative momentum transfer. You throw the ball, but it delivers negative motion in your direction. That's okay. Mathematically, you just change the sign from a positive to a negative, right? That's it. And so instead of having positive, momentum, for example, you have negative momentum. Great. So now all you did was change the sign, which is a physical issue because now they're saying, look, that changed the direction of motion. There is no such thing as direction of motion in mathematics. Okay. So by changing the sign, all you did was suddenly you ventured into physics. Okay, without anyone knowing, and say, well, I'm still doing math, and we have no problem with that because we changed the sign, and suddenly the direction of motion is in the opposite direction. That's not math. That's jumping over into physics without without substantiating it, and just saying that we change the sign and suddenly the direction of motion changes. Okay, again, that's a big leap of more than faith. It's ridiculous. Okay, okay, so here we have it. Okay, this is how we explain it because all atoms in the universe are physically interconnected. Every atom of that astronaut is connected to every atom on Earth. Every atom on Earth is connected to every atom of that astronaut. And the reason he accelerates towards the Earth is as he falls, more and more independent ropes are acting on every one of the atoms in his body. Okay? So as you widen, ropes are not on the same axis. That's what's happening. They are fanning out. And so you have more what we call independent ropes tugging on that astronaut. And that's the reason for the acceleration of gravity. We have a cause, a physical interpretation for the acceleration of gravity. Okay? That's what we're showing here. You say, well, is that true? Okay? And here you see it. Here's the spoon falling towards Earth again. Okay? And what's happening, every atom of that spoon is connected to every atom on Earth Obviously, I didn't draw every atom. I didn't draw every rope that's connecting all the atoms, binding all these atoms. But you get the idea that as it falls, the ropes are fanning out. Okay, there are more ropes that are in what we call independent ropes, that they're not on the same axis anymore. That explains the acceleration of gravity. Okay, and so one of the questions people say, well, uh, how does it work? Here it is, synthesis, okay, so that you can get the idea. Okay, you have all atoms interconnected between two objects, object one and object two. We can talk about their masses, in other words, how much they weigh if you want, how many kilograms you got in there in each one. And you have distance separating two objects. The farther away two objects are from each other, like you see there on the upper right, the more they act as one. And the closer they are together, you can see that the ropes are fanning out and you have more independent ropes because they are not on the same axis. This explains, this is a physical interpretation for the acceleration of gravity. Now the ropes don't pull. Each rope does not really pull. What you have is tension between any two atoms. The ropes are only under tension. We use the word pull because we're so used to seeing one object fall towards another, and we say, oh, one object pulled on the other. But what's actually happening is the distance shortens because one object, as it approaches the other, the ropes fan out, and there is no pull within a rope. All you have is tension. That's why, in Newton's force law, we replace the F force, replace it with T for tension, and there is tension is not a force. Only in the religion of mathematics is force, tension a force. In other words, they're synonyms, not in science. In physics, tension is not a force. Force, if you look up the definition, it'll tell you that someone has to win the tug of war, and that's not the case of tension. In the case of force, something has to move in one direction or another. In the case of tension, at least between two atoms bound by a single rope, there is no one wins the tug of war. There's constant tension on it, and the tension is defined by the velocity of light squared, by the velocity of light, which is a constant in the universe. So that is a measure of the tension on the rope. Okay, and you say, well, where did you get this? Well, we got this from Mr. Muller here. You can, not that I got it from him, but he reinforces this. He says, look, every atom on Earth is pulling on every atom of you. You are also pulling on it. The amazing thing about gravity is that it goes right through things. Okay, so I want every one of you tonight, especially if you pray every night before going to bed, I want you to say the Lord's Prayer tonight. Okay, the Lord Bill's Prayer, and here's the Lord Bill's prayer, and I want you to memorize it. Okay, so that you can recite it every night before going to bed. Okay, here it is. Okay. Every atom on Earth is pulling on every atom of you. You are also pulling on it. The amazing thing about gravity is that it goes right through things. Okay? So I want you to memorize the Lord Bill's prayer and recite it every night so that you know how gravity works. And there you have the whole key. That's the whole mystery of gravity right there in front of you. Okay? Every atom of you is pulling on every atom of the earth, and every atom of the earth is pulling on you. That is the description and explanation of gravity.